Welcome all my dear student of TYBSc physics class. Today we are going to see numerical methods, and first numerical method is bisection method. Now in this bisection method we should know what is the bisection method. Bisection method is a simple and reliable iterative method. This method is also known as half interval method. Okay, this method is based on the theorem which state that if a function f of x is continuous between x0 and x1 and f of x0 and f of x1 are of opposite sign, that is f of x0 into f of x1 is less than 0, then there exists at least one root between x0 and x1. Okay, I think this is very familiar, or you are very familiar with this, because already in 12th science as well as in mathematics of TYBSc and SOMAIYA you learned bisection method and Newton-Raphson method, that is numerical methods. Okay. Now in order to understand this bisection method, consider this figure. In this figure, this is a continuous function and this is the part of function f of x. We begin by picking 2 points, x0 and x1, this point and this point, which encloses a root f of x0 at x is equal to x0 and x is equal to x1, that is here. Okay, what I say, we begin by picking 2 points which encloses roots, and the function is f of x is equal to 0 at x is equal to 0 and x is equal to 1. Therefore, this x0 and x1 are roots of f of x. x0 and x1 are root of f of x, where x and f of x may be complex, real or vector quantities. Now we select 2 points x0 and x1 which enclose a root, that is root is nothing but suppose x2. Hence that is x2 lies in between x0 and x1. From this figure we can say that f of x is equal to negative here, f of x for this is for negative value, negative when x is equal to x0, and the function f of x is equal to positive value when x is equal to x1. That means what? The function is negative when x is equal to x of 0. Okay, and when function is having positive value when x is equal to x1. Thus f of x0 and f of x1 have opposite sign, minus and plus. If root lies between x0 and x1, therefore we can say that, very important, f of x0 into f of x1 is less than 0. Okay, this is very important. The root of function lies between x0 and x1. Okay, then let us assume another midpoint, say x2. Another point, say x2, such that x2 is equal to x0 plus x1 upon x2. This is the midpoint, or we can say that point x2 lies exactly in the interval AB. That means point here x2. This is the interval of x0 and x1 as shown in figure. The point x2 divides the interval of, the point x2 is divided in the interval of x0 and x1, or we can say that the point x2 divides interval in half. Okay. From this figure we can say that f of x0 and f of x1 have opposite sign. One of them, x0 is having minus sign and x1 is having plus sign. Hence root lies between x0 and x1. We further divide new interval into two halves, into two halves with new interval AC as shown in this figure. Now let us, next point will be x3 is equal to x0 plus x2 upon 2. Again it is clear that if f of x3 function at this point and f of x2 have opposite sign, again here x0 is minus and x2 is plus. Therefore we get new interval between x2 and this is the new interval. This method continues until the interval containing the roots is as small as possible as we desire. Okay. If small error, say epsilon, is allowed in between actual value and approximate value of root, then number of steps required are given by n is less than or equal to log, say x1 minus x0 minus log of small error divided by log 2. This is very important formula. Okay. When n is a number of steps or iteration required and x0 and x1 is interval taken. Okay. In this way we can study the method of bisection method, and this is very simple for you because you are already learned in 12th science and at FY and SY level. Okay. Now I am going to tell you about algorithm. That means perfect procedure in order to find the root by using bisection method. Okay. See here, algorithm is simple. Just I told you that algorithm is nothing but systematic procedure in order to find the desired solution by applying the proper and logical operation. Okay. So what we have to do in order to determine the root? First of all, we have to read the interval. That means initial value of x0 and x1. So in the algorithm, first step is first, read interval x0, x1 and error. Okay. Error, that means permissible error. Okay. epsilon, say epsilon. Now when we read the error, in second step we have to calculate number of steps. We have to calculate number of steps by using formula, that is step second. We have to calculate number of steps by using formula, same formula, n is less than or equal to log x1 minus x0 minus log epsilon, okay, upon log 2. After this, in third step we have to calculate midpoint. That means in step third, calculate midpoint, and midpoint is very simple. What is the midpoint? x2 is equal to x0 plus x1 upon 2. By using this formula we can calculate the midpoint. Now in next step, that is in step number 4, after calculating the midpoint, suppose we calculate midpoint here, and then we have to decide, or we have to check the sign of f of x0 and f of x1, either it is positive or negative. So calculate in step 4, calculate first f of x at x is equal to x0, that is f of x0. First calculate this. Then second, calculate the value of x at x of x is equal to x1, that is f of x1, okay, and f of x at where x is equal to x2 for f of x2. And from this we have to check the sign by putting the simply value of x in a given function. Calculate the value of f of x at x0, f of x at x1, f of x at x2, and along from this, in between this or from this 3 or 4, we have to check the sign of function at x0 and x1. So in next step 5, we have to check if f of x0 into f of x1 is less than 0, then we have to decide, or we can say that then according to this formula, then the root lies in between x0 and x1, okay, and after then we can then replace x0 by x1 for next interval, x1 by x2, x1 by x2. We have to replace this x1 by x2, that means this is the second interval, okay. If it is not so, that means we can say that if f of x zero into f of x, say f of x1, function x1 and f of x2 is less than 0, then function lies here to this side, and we have to replace x0, the root lies between x1 and x2, okay. After then replace x1 by x2, okay. Here x1 by x2, here we have to replace value of x0 by x2, okay. Are you got it? If f of x0 and f of x1 is less than 0, then what? Root lies in between where? x0 and x1. Sorry, not x0 and x2. That's where x0 and x2 root lies here. And then replace this x0 by x2. Otherwise, if function f of x1 and function x2 is less than 0, then roots lies in between where? x1 and x2 from this side. And at that time we have to replace value of x0 by simply x2. Okay, in this way. This is very simple. Okay. Now, step 1, step 2, step 3, step 4 and step 5. Okay. After then, we have to repeat the same procedure. That means what? We have to repeat step 3, 4 and 5 until number of iterations are completed. Or repeat step 3 to 5 until value of x2, repeat value of x2 repeats up to given significant digit after decimal point. Okay. And last, this is the happen in second step. That's what for next step, that means step number 6, what we have to do? We have to repeat step 3 to 5 until number of iterations are completed, or repeat step 3 to 5 until x repeats up to given significant digits after decimal points. Okay. And in step 7, what we have to do? Simply we have to find out, or we have to calculate the approximate value is equal to the center point of latest interval. And then in step 8, we have to print the value of root, and in step 9 we have to stop. Okay. Therefore, in this way we can observe, or we can study algorithm for bisection method, which is very simple. Okay. Now, according to this algorithm, we can draw flowchart. See here, flowchart is nothing but pictorial view or graphical representation of this algorithm. All the steps are shown in flowchart, which will be studied in algorithm. So, step first, whole start. This is the first step. Then in next step, what we have to do? We have to read input or interval x0, x1 and error. This is the first step of algorithm. Start, then we have to read the input, then calculate the value of n. N is less than or equal to log A minus log B. That means calculate n for given error. That means by using the formula n is less than or equal to log x1 minus x0 minus log of error into divided by log 2. By using this formula, we can calculate value of n, which is completely done. Then we are going to calculate the midpoint, that is x2 is equal to x0 plus x1 upon 2. This is shown in 4th stage, that is in this block. All these are the line of flow. Then after then we have to calculate what? F of x0, f of x1, f of x2, etc. After calculating the value of x0, x1, after the calculating value of f of x0, f of x1 and f of x2, we have to decide by using this decision block. If first f of x0 into f of x1 is less than 0, if yes, then replace x1 by x2 when if condition is true, and when condition is false, then go further, that is no. Okay. Now we know always here there is a no space, so we are making a block here, continuation. Due to lack of space, we can continue here. If this condition is not true, then if this condition is failed, then we have to check next decision block. If, what is the next condition? If f of x0 into f of x1, x2 is less than 0. Okay, just a minute, I want to check the condition. F of x1 and f of x2 is less than 0, then what we have to do? If condition is true, this is the connector which connect here. If this condition is true, yes, then replace x0 by x1, or simply we can say that value of condition is true, then replace the value of x0 by x1, and then this is the connector here. Okay, and simply come here. Okay. Now again we have to check the steps. If n is less than or equal to 0, if condition is true, then simply come here, and if condition is false, condition is not true, then go back. This is the connector, and this connector is connected here, and from this point we simply come here. Okay, in this way, and then after then we have to calculate the root x2. Root is nothing but x2, and in step number 8 we have to print the value of root, and in step 9, last step, we have to stop. Okay, see here, this is the flowchart, and flowchart is nothing but the pictorial or graphical representation of algorithm. Okay, now in next lecture we will study the example or examples of bisection method, which are very important for exam point of view, and this is very easy for you because such type of examples are studied by yourself at the level of 12th standard as well as at TYBSc and SOMAIYA. Okay, till then we shall stop here. Have a good day. Thank you.